had these forever and I totally forgot about them. Trophies from your state tournament. I think y'all swept the award. They only give out 3 trophies in the state tournament, which is pretty impressive. But we had third place J-Dubs. Yeah. We had second place Nathan, he's in the other class, and total domination by Lily.
Oh yeah.
First place.
Oh yeah, Lily.
Pretty solid. Oh wait, I got other stuff too. A ton of you. They just have like, they don't put like your name you go by. They go by. All right, this is 24th place overall. Got 24th, 23rd. 19th, 16th, another 16th, 13th, 13th, 12th, 11th, and you killed it. 9th, it's really quite selfish to take all the awards like that. 8th, 5th, 4th, 3rd, 2nd, 1st. Wow. Yeah, and that's a different class. Okay. So Russell, 24th place. We also had Andrew Laird was 26th. He's no class. Bailey was 23rd. James was 19th. Sam, 16th. Kaylin Rezick was 16th. James Reardon, 13th. Sophie, 13th. Mary was 12th. Thomas was 11th. Maddie was 9th. Luke was 8th. Isaac was 5th. And Kieran was 4th, and then JW was 3rd, Nathan was 2nd, and Lily was 1st. Pretty impressive, guys. I think that was one of the bigger beatdowns in the history of geometry. Anyway, in terms of like stealing almost all the awards. Sorry I haven't given those out earlier. I completely forgot I had. So let's jump to, nobody had any questions from yesterday. Feel really good about it. All right, so here we go. Today I want to just stretch it out a little bit and start talking about division, multiplication, when we're really starting to put something together. So instead of having just a single term, what happens when you have terms divided by terms, terms multiplied by terms, that when they're dealing with radicals of all different kinds, whether they're cube roots or square roots or fourth roots. But what I also want to throw in there is what do you do when there's addition? Now, this right here is one of the biggest mistakes I see. They think if you're square rooting a sum, that would be the same thing as square rooting each part. But that is not true, okay? And to show you that, what if I had the square root of 2 squared plus 3 squared? Now you know that that's the square root of what? 4 and 9 is 13, square root of 13. But if I did this, that would give me 2 plus 3. And 2 plus 3 is 5. And although 5 is 5, and that is certainly not that, because this is square root of 13, which is like 3 point something. So make sure you don't do that. I see this mistake. I see this mistake a lot. They go square root of 9 minus x squared. Oh yeah, that's a perfect square trinomial. So it simplifies to 3 minus x. But it's not a perfect square trinomial. It's 3 minus x, 3 plus x, which are different, right? And if they're different, you can't simplify that. Now, if it's that, yes, that's the same thing twice. Why am I saying not equal? Because what's my rule? Absolute value of this. And that's another big mistake I see a lot of. So if you see a square of a squared or square root of a squared, remember that's going to be an absolute value, unless that 2 is on the outside, in which case you wouldn't need it. So you got to remember those rules, right? If that's an even root, you're going to have absolute value if that number's on the inside. If it's on the outside, you don't have to worry about it. So think about all those, and then I'm going to talk a little bit about rationalizing again. When you're rationalizing a denominator, which by the way, when you get to calculus, nobody cares. Like this is totally an algebra 2 pre-cal thing. You get to calculus and you want to leave your answer as 1 divided by root 3, leave it. Nobody cares. Now your calculus teacher in college might care, AP test, nobody cares. But here, algebra 2 and pre-cal, that's one of the things they ask that you get taught is how to rationalize denominators. So right now there's a root over it, that's irrational. So we need to get rid of that root. And a lot of people, like I mentioned yesterday, build bad habits from stuff like this. And they think, oh, to get rid of it, you just multiply by root 5 over root 5. And that is a way to get rid of it when it's a square root, because what did I end up with? The square root of 5 squared, which simplifies. But if it's a cube root, okay, then I would need 3 of whatever's under there. If it's a 4th root, I would need 4. So when I look at this right here, nothing cancels out of that. By the way, there might be a better way to do this, so I'm going to hold off on that. Right here, nothing can cancel in that fraction that's in there. So what would I have to do to rationalize this? And remember, a cube root of a whole thing is the same thing as what? Of the top and the cube root of the bottom. That's this rule that I'm talking about. Well, we talked about it earlier. Same as the square root of the whole thing is the square root of each part if you're multiplying or dividing, not if you're adding and subtracting. Okay, so right here, how many, if it's a cube root, how many 4s or b's or 2's or whatever do you need to be able to simplify there?
So times 2b squared.
So I need groups of 3, don't I? So right there, if you look at that 4 as a 2 times a 2, then I'm going to need to rationalize with 1 more 2. Are y'all with me on that? I need an extra 2 there, so that I'll have a total of 8, and I can take the cube root of that 8. And I need it on the top as well as the bottom if I'm going to be keeping these equal. Now the b to the 4th, you could, I guess, think about that b to the 4th as b cubed b, since there's 4 of them. And if that's the case, could I have already taken a b out? Yes, no? So if I did that and took a b out, I would have a b in the denominator over there on the outside, and I would have 1 b left. But if I have 1 b, how many additional b's would I need? 2 more, so I'm going to have a b squared and a b squared. And again, write it on the top and the bottom. Now, when I multiply all this together now, I already have the b outside on the bottom. I'm left with a cube root. Move this over, leave myself some space. I have a cube root of 27a 2b squared. Does any of that simplify? So again, I could have taken that 27, taken the cube root of it, and pulled a 3 out if I wanted to, and that leaves me a, 2, and a b squared. Is any of that going to simplify with a cubed root? Not, the b does not come out, right? Because it's not a square root. So if nothing comes out, I'm going to leave the 2, the a, and the b squared there. And then tell me about the rest. What do I have left here? On the bottom, I still have a cube root of what? 8 b cubed. And the whole point of that, you don't have to write this step. The point of this was now that I can cube root the 8, what's on the outside? 2. And now that I can cube root the b cubed, what's on the outside? another b. So I can square that, and now I don't have anything left under that radical, so you shouldn't have anything left under the radical when you simplify this. Are you seeing that? That's rationalizing a denominator that's not a nice, neat square root. It's a cube root or a fourth root. Now on this one right here, is there anything I could do before I got started?
Yeah.
What?
You could cube root the 8.
If I cube root the 8, that's a 2. Bring the 2 out. Leaves nothing left in the denominator.
You could make that 81 3 cubed times 3.
Good, because 81 is 3 to the 4th. That's the same thing as 3 cubed times 3. So I can do what with that 3 cubed and 3 if it's a cubed root?
Pull the 3 out and leave the 3 in there.
Pull one of the 3's out, leave the other cube root there, so I'm left with 3 cube roots of 3 over a 2. And I didn't even have to rationalize. Now if you do rationalize on that thing and put 2 more 8's on the bottom, you're going to also have 2 more 8's on the top. You're going to end up simplifying all of that stuff, and then you're going to cancel a bunch of stuff, and you're going to be right back to here. So to me, I like to look at it, make sure I clean it up before I get started. What about this? So she's suggesting to divide 60 by 5. Am I allowed to do that?
Yeah.
If they're both under the radical, that's the same thing as just a fraction, isn't it? You don't have to rewrite it that way. But if that's the same thing as this, then clearly I can simplify that right there, and all I would have left is a root 12. So I would probably skip that step and just cancel, cancel, and go straight to the root 12. Can I do anything with that root 12? Yeah, so root 12 is root 4 times root 3, so 2 root 3. And again, guys, you don't have to show a lot of work on these. I know a lot of you can do this, a lot of it in your head. That's fine, but again, the more work you do show, the better off you're going to be when you make errors, because I can give you partial credit. If it's just an answer, then it's either right or wrong. What about this next line? Square root of 2a squared b. There's no denominator, but what would you do to simplify it?
Take an A out.
Do what?
Take an A out.
Take an a out? What would I be left with?
Maybe.
Okay, why would I do this to you? Why would I slash you? Technically, I should probably take off even more than that, because that's the only thing that I'm looking for. But I'd probably give you a little kindness. What am I missing? Absolute value. Remember, that is the same thing as square root of 2, square root of a squared, square root of b, right? What is that? Absolute value of the a. You got to remember, if it's an even root and you bring something out of it and it's a variable, you have to leave the absolute value on it. All right, what about this thing? So there's 5 x's. That's like an x cubed and an x squared. Couldn't you cube root the x cubed part and bring an x out? And what would I have left beneath that radical? X squared, and then couldn't I cube root the y cubed and have a y? Y'all with me on that? What about 6? Notice there's a plus. Can I do this? When there's a plus right here. It looks so good. I cannot do that. What can I do?
You can bring a 4 out. Or no, you can
Oh.
bring 2 out.
So I could factor it, which is kind of what I have. These are all kind of factored, right? I could factor it, and that's as good as I can get factoring it. And if it's factored, then I can think about it as root 4 times root a squared plus b squared. And in that case, what would I have? But I cannot do anything else with this, can I?
Yeah.
That's such a sucker problem right there. People so many times just end up with 2a plus 2b. Be really careful. What about this cubed root on number 7?
You can look at that as
It's a cube root. How many 5s is that? 4 of them. So if there's 4 5s there in a cube root, I can do what?
Bring 3 of them out.
I can cancel 3 of them to bring 1 out,
Yes.
and that would leave me with a 5 still under there. Does that make sense? Because that's like a 5 cubed and a 5. What about the x to the 6th? That's like an x cubed, so I can bring an x representing each of those, x squared. What about the y's? You can take 2 out, right? Because it's like a y cubed, y. So I can take 2 y's out, leaving me a y though. And then what about the z's? Right, that's like a z cubed, with an extra z. So I can bring 4 of those out with a z left over. Are y'all able to see that? Okay. And do I need any absolute value on this? Why? Odd root. All right, what about this thing? It's a square root.
Wait.
Cancel out 5 squared. And there's 5 in there.
So that's 5 squared and 5, so I can bring a 5 out, leaving a 5 in.
For the number 7 one, why isn't it just a 25 cubed? Well, it's 25, right?
That's not 25 cubed. That's 5 to the 4th. It's 25 squared.
Okay.
All right, so what about the x's here? Square root.
Absolute value of X.
Nice. It's really easy to go, oh, that's x squared, which is true. But when I square root an x squared, I get absolute value of x. So either absolute value of x with the cubed or absolute value of x cubed. It really doesn't matter. Now what about the y?
Y cubed and absolute value of y cubed and leave y in there.
Absolute value of y cubed, so same thing, but I have an extra y left over. Leave myself some room here. And then, what about these z's?
Z to the 6. And then leave a z in there. Absolute value of z to the 6.
Now, do I need absolute value on the z? Why not? Yeah, the 6 would have made it positive anyway, wouldn't it? Since the 6 is even, would that have made whatever that is positive?
And why didn't you get up for y? Because that's equal to, because you said like
It's
y
three.
to 6.
Well, it was why the 6 in here. But my point is, what is the 6 doing to that?
Making it positive.
Right. What is the 3 doing that? Keeping its sign.
So like,
So technically, that's true. But if you're really trying to simplify, I'm just saying leaving both of those under an absolute value is necessary because the 3 would never have made them positive, would they?
so you put it like that for like the problem above, and then you like look at it and say that would just automatically be positive.
Yeah, I'm just observing it at the end, observing it saying, since it's automatically positive now at the end,
There's no point.
so it doesn't matter about it being even in here. That's not what I'm saying. Like, that is a y to the 6th in here. That's not how I'm deciding this. I'm saying that once I bring it out, if it's not necessary to make something positive because something else is already doing it, you could avoid that. And I can tell you that this is such a rarely dealt with issue. I'm just trying to get y'all to be perfect about something. But it's not like this shows up all day, and it's not like I'm going to take off much on your test. It probably pops up once or twice for 1 or 2 points total. So it's not a massive topic, but it is important. Most of the time, you don't have to worry about it. What about this 4th root in the denominator?
You have to make it.
So I'm gonna have to
Make
rationalize.
it 16, make it 2 16.
So I gotta make everything a power of 4, and whatever I do on the bottom, I've gotta also do in the numerator. So how many more 2's do I need to simplify this 4th root?
3.
3 more 2's, so I'm just gonna put 8 there. How many more c's do I need?
2.
2. And how many more d's?
3.
3. So I'm gonna keep that the same on the top and the bottom. Now, is anything gonna simplify in that numerator?
No.
No. So leave 8c squared d cubed. But in the bottom, isn't the bottom now essentially this 16c to the 4th d to the 4th? So if that's what the bottom is, what does it simplify to?
2cd.
2
Absolute value of cd.
absolute value of c and d. And why didn't the 2 have to be in the absolute value?
Because we already know the value.
Because absolute value of 2 is 2. Exactly, I already know the value of it. It's positive, I don't have to make it positive. But I don't know the value of c and d, so I have to ensure that they stay positive. Now, when you do your homework tonight, you're gonna notice a huge, if it's bookwork, you're gonna notice a huge omission of absolute value. Why are they skipping the absolute value? Why don't they acknowledge it? And when you read back through the directions, you'll see something like this. Assume x and y represent positive numbers. And this is basically, they're trying to soften it for you, but this is a pre-AP class, so we're gonna raise the bar a little bit. But the reason why they might not include absolute value there, because in the problem, they probably stated, assume C or D are positive. Well, if they're already positive, then I don't have to say that, do I? But we should get in a good habit, and if you wanna go ahead and get in the habit of that when you have even roots, it's a good practice. All right, what about this? What about when I start mixing stuff up and I have problems that have radicals in the top and the bottom that already have stuff, maybe not everything, but some stuff pulled out. And again, notice it's all multiplication or division. What do we got?
First rationalize it.
Now, you're totally okay doing that. You're totally okay doing that. But is there something else I could do?
Divide now.
Yeah, you can
So,
divide down.
numbers on the outside can be divided because they are factors, right? It's all multiplication.
Yeah.
But also numbers on the inside could be canceled as well, because again, it's like it's one big radical. So that would cancel with that, leaving a 2. So really, all I have to deal with is this. So what would you do to rationalize this?
Times root 2.
Times root 2 over root 2, and I get
root 2.
root 2 over 6. What about on this next one?
Probably divide the 2 down and get,
So I can cancel that with that.
make the bottom one 2. Cancel the top and bottom, make the top is 1 and the bottom is 5.
It's a 5 under the radical, right? And what about the x's?
X squared.
So I can cancel that x with that x cubed, giving an x squared. So let me clean that up. I still have an x squared in the numerator. I have a 2 on the outside, and I have a square root of 5x squared. Now at this point, can I do anything?
Multiply by, or you can pull out the X in the denominator.
Okay, so I could pull an x out. That would get me to here. And I know some of you can take less steps. Am I pulling an x out though?
No, you're pulling out X squared, absolute value. And then you multiply by root 5 to clear it.
Now, here's where I am right now. X squared root 5 over 2 absolute value of x times a 5, because all that becomes a 5, right? Which gives me this. Now I want you to tell me, can I simplify this?
Can you,
No, because it's too
It's kind of like a different version of x, isn't it? So hypothetically, if I plug a 2 in here, a positive 2, what would I get?
you get 4.
4 root 5, if x is 2. I would get, I probably can't read that. So hypothetically, I want to just show you something. If x were 2, I would get 4 root 5 over 20, right? Which would give me root 5 over 5. You with me? And if x were negative 2, what would I get?
Still 4.
Still
Or still
4
2.
root 5 over a what?
2. Or 20.
Still positive 20, right? Absolute value?
Yeah.
Are you seeing this? Positive 20, so still root 5 over 5. So leaving it like this is fine, but is there some other option maybe I could do? I'm getting positives on both. What if I thought of that as absolute value of x squared? Is it still x squared?
Yeah.
Yes.
And then I could cancel an absolute value of x
X root 5 over 10.
over 10. Would my rule still work? If I plug a 2 in, do I still get? Let's
Yes.
try it with this. I get 2 root 5 over 10, still 5 root 5, right? If I plug a negative 2 in, what do I get?
Same thing.
2 root 5 over 5, still root 5 over 5. So if you ever end up with like a root x on the bottom and some other x's on the top that are raised to a power, if it's an even power, root x squared is the same thing as x squared. You could have that luxury and just cancel those out. Again, not something you see every day, but I'm just throwing stuff at you. Now, sums of radicals. I want to talk about those. Sums of radicals are like like terms. Can you add 2x plus 3x squared? No. Can you add x cubes and x cubes, or add or subtract x cubes and x cubes? Yes, and you do that by doing what? You learn to just keep the x cubed and add the coefficients or subtract the coefficients. Do you know that that's really factoring? You're basically looking at this and factoring out an x cubed, and you're left with 2 minus 5, which is negative 3x cubed. Well, with square roots, cube roots, any other roots, same thing. If I'm dealing with radicals, I want you to think of a radical like an x or a 2, root 2 or a 5. Think about them like you're looking at like terms. If one of them's root x and the other one's cube root of x, that's like x's with different powers. You cannot combine them. Okay? If I have numbers like root 2 and root 5, that's like having an x and a y. You cannot combine them. If I have the same radical though, that's like having the same variable with the same power. So you can essentially factor out that root 7 and you're left with 2 minus 5, which is negative 3. Are y'all seeing that? So when you're adding and subtracting, you have to have like terms. Same thing with radicals. And sometimes they're going to mess with you, and it's going to look like you don't have them, but you really are going to have them. So let's walk through a few of these. First one, number 12. Can you add 3 root 2 plus 5 root 2?
Yes.
And you get?
A root 2.
A root 2, great. Can you add 5 root 3 minus 18 root 3?
Yes.
Yes, and you get?
Negative 13.
Negative 13 root 3. Can you add 4 root 2 plus 4 root 3?
No.
No. Now for those of you who think, yeah, but you could factor 4 out, you can, but what is my goal for this, most likely?
Simplify.
Simplify. Is there F for factor and simplify?
No.
No, not unless it helps me divide. So I would not want to do that. I would just circle that and call it a day. What about something like this? Can you add these? Now, at first glance, maybe no, but I haven't simplified them yet. And if I do simplify, maybe I do have the same radicals. Are you tracking with me? So right here, what is 12?
2 root 3.
So I could bring a 2 out to go with that 3 and leave the root 3 part underneath. And what is that? 9 times 3? So I could take the square root of the 9 part and bring the 3 out with the 12 and leave the other part of the 3 left. Now do I have like radicals?
Yes.
So how would I add them?
42 root 3.
42 root 3. Now something like this, it kind of looks like I don't have like numbers at all, but this thing's not even rationalized yet. So again, and plus, I might be able to find a common denominator and get somewhere. So what would you do first to maybe see if these are the same?
Times root 2
Okay, so we're going to rationalize this thing. That gives me root 6y over a 2. Now that I have the same radical, can I subtract them? If I had what? Common denominator? So how about 2 on the top, 2 on the bottom? And what does that give me now? 2 blah minus 1 blah is 1 blah divided by 2. Now what about this thing? Zillions of different ways you can start approaching this, but what would you do to do it?
Simplify the stuff and
Okay, if you wanted to, you can totally simplify this. This is one way to go. You could say that that's a 2 root 2 plus a root 10, and then you get to here. But then what are you about to do? Then you're going to distribute. And when you distribute, now you've got 2 root 4 plus root 20, and you still are going to have to simplify some. And you're fine to do that. What would this simplify to? That ends up being a 2 times 2 is a 4, and what does that simplify to? And you're totally fine if you want to do it that way. But you're also fine if you're like, you know what, I'm just going to multiply it in and simplify it when I'm done. If I multiply it in, what do I get? Root 16 plus root 20, 4 plus 2 root 5. So I don't care how you do it. Sometimes one way is better than another, but just know that if you stick to your PEMDAS, I think you'll be in pretty safe shape here. All right, what about, come on down a little bit, 18, 19, 20. Any ideas on this?
Rationalize.
You want to rationalize first? That is an option. So if I rationalize first, I would have roots, if you rationalize first. Root 2 over root 2, right? How would you do it at this point?
Well, you have 2 on the bottom and then
2 on the bottom.
you distribute it to root 2.
If you distribute that in, you get root 12 minus root 48. Now, can you simplify that any? How? So that right there is a
2 root 3.
2 root 3. What times what gives me 48? A lot of different things. 16 and 3 are great, right? Square root of 16 is 4 with the root 3 left over. Can I simplify that?
Yes.
Which gives me, and then that, 1, 2, 3, 4, 5 steps. Is there a better way? What?
You can cancel it to
I could factor out a root 2 if you wanted and cancel, or I don't even think like that. I think, do you remember how when you add fractions with common denominators, you get a plus c over b? Right? Doesn't that imply that if you have a fraction, you can put the a over the b and the c over the b to get back to here? So what if I have this fraction and I put root 6 over root 2? What does that give me? Root 3. What if I put root 22 or 24 over root 2? What would that give me? Root 12. And then I get root 3 minus 2 root 3. And what's 1 root 3 minus 2 root 3? Again, 3 steps versus 1, 2, 3, 4. You might save a little bit of time. Just one more way to do it. What about 19? I know. It's like, where do I even start? What's the shortest way? Who cares? Just pick something. What's the first thing that pops in your head? Like, I'm a bigger fan of distributing. But you could, and the reason why is because I have this bad feeling that if I rationalize now, then when I multiply it out, I'm going to have a bigger mess and I still have to deal with stuff. So I'm going to just distribute. What do I end up with when I distribute that in there? Be careful. What's root 3 times root 3?
3.
What's root 8 times root 4? And if you don't want to worry about it now, just write root 32 and deal with it later. Okay? You don't have to try to do all that in your head. Just play it safe. Now, plus what? What's root 3 times 2?
2 root 3.
And what's root 8 times root 3?
Root 24.
Root 24. Just play it safe if you want. Now, if you wanted to clean up some of that ahead of time, you could have. I'm just saying. Now, at this point, is there anything I can clean up on this?
16 and 2.
That's 16 and 2, so 3 over what?
4 root 2.
4 root 2, good. What about this one?
That's 2 root 6.
It is 2 root 6, but could I cancel something before I even do that?
Oh yeah, you can cancel out the root 3 with the 24.
So how would I clean up 2 over root 8? What's root 8 when you have that left?
2 root 2.
Okay, now at this point, yeah, I could actually cancel the 2's out if I wanted. But at this point, what would I have to do to add these?
Get a common denominator.
Probably find a common denominator, and I got to do that. I probably also want to rationalize. So what would I do to rationalize the left side? Root 2 over root 2. And guys, be careful. Don't just do times a root 2. You want to do times a root 2 on both. So that gives me 8 on the bottom. And then here when I rationalize, it gives me 2 on the bottom. And then what would I have to do at this point to add these together? So 4 on the right side on both, and that gives me a common denominator. So what's 3 root 2 plus 4 root 2? 7 root 2 over 8, and nothing cancels at that point. Because you can't cancel a number on the inside of a radical with a number that's not under a radical. Y'all seen this? If you're bored, I'm really kind of happy. It's not, I mean, I don't ever really want you to be bored, but if you're getting this great. What about this thing? Should I rationalize right now?
No.
Why not?
That's gonna be a lot of multiplying.
It's going to be a lot of multiplying, and what can I do right now?
You can take out.
Because it's plus, I can use that rule that I just talked about. So what's root 18 over root 3? Cube root of 18, cube root of 3. Cube root of 6 plus, what's 3 cube root of 54 over cube root of 3? Cube root of 18. And that looks better already. I don't have to rationalize now. But can I simplify anything there? It looks like you can at first glance, but can I?
Yeah, you can.
I can? Show me how. What's 9? 3 and 2. But you need 3 of something to simplify, don't you? So can I do anything here?
No.
So I'm stuck, I just leave. Okay, now binomials. Okay, if you have binomials that have radicals in them, don't make this rocket science. if I give you this kind of stuff, just FOIL it out or distribute it out. All right, so stuff like this, a single number, like a 2 root 2 on the outside of a binomial, distribute it in. Simplify it and then try to clean up the radicals as much as you can. If you have something like this, FOIL, right? First times first, last times last. Inside, inside, outside, outside. Well, FOIL, first, last, inner, outer. Sorry, first, outer, inner, last. Do the FOIL. Are you with me? But don't try to do too much in your head. Like right here, I took that times both of those. Here I am. There's my first and my outer. Then I took the 4 times both of those. There's my inner and my last. Take the time to actually distribute these out and then go back and look at them and say, can I clean them up? And most of the time on the work you do, you're probably going to be able to clean that thing up a little bit. Sometimes you can add these two things together, and in the end you might even be able to add a little bit more together. Are y'all with me? And that's especially true when you have the same radicals up here in the original problem. If that had been root 3 and root 5, you're probably just going to have a big mess. But a lot of the time, you see the same radical there, and it's really going to simplify it pretty nicely. So check it out. Right here, what would you do to rationalize? And you might remember this, you might not. Do what? I think you do. Do what?
I think you do like root 2 minus root 3.
She's suggesting use root 2 minus root 3. Now, why would that help? Tell me. What's special about a plus a number and a minus a number?
There's no like, there will be no root 6.
There's no middle terms. When I do this, I get a squared minus ab plus ab minus b squared. My middle terms are gone. Well, when I FOIL that out, I'm going to get root 4, which I probably wouldn't write as root 4. I'm going to get negative root 6, positive root 6, and negative root 9. And the root 6's would never have simplified, would they? But if I choose what we call a conjugate, which is, these are conjugates of each other, then the oi of your FOIL, the oi cancels. And that's huge for you because now I don't have any more irrational stuff in there. All I have is the 2 minus the 3. Now the top part, who knows what I'm going to have? Root 6 minus root 9. So I end up getting root 6 on the top minus a 3 over a 2 minus a 3. And that gives me root 6 minus 3 over a negative 1. And is there anything I could do with that? I hate negatives on the bottom. What can I do to get the negative off the bottom?
Side or up top.
I could take that off the side, or just think this. Can I multiply the top and the bottom by a negative? If I do that, what do I get?
3 minus root 6.
Negative root 6 plus a 3, or even better, 3 minus root 6 over a positive 1. So either that, or a lot of people like switching the order to make the negative in the middle, but I don't care. So when you're getting rid of a binomial, always use a conjugate. So what would you use here? What's the conjugate of this?
Or plus 7.
Root 3 plus a root 7. Now the bottom part, what's going to happen when you multiply them? When you FOIL it out, the oi is always going to cancel, right? So can I skip that part and just go first times first is 3. Last times last is 7. I'm going to subtract those and end up with a negative 4 on the bottom. But on the top, I'm just going to have to suck it up. So let's start. Root 15. Root 35. Root 6. Root 14. So I get all that junk, I'm going to write it here. Root 15 plus root 35 plus root 6 plus root 14. Very uncommon to get something this ugly over a negative 4. And what could I do to make that look a little prettier? I could multiply the top and the bottom by a negative. And in doing that, what ends up happening? That becomes I'll just do it. Multiply the top by a negative and the bottom by a negative. And you end up with all of that negative over a 4. And again, sometimes you're not going to get it simplified all that. It's pretty rare to see in a textbook problem. Most of the time your textbook problems look like number 23, where they have the same radicals involved. So check out 23. What do I got here?
5 root 3 minus 7 root
So conjugate would be 5 root 3 on the bottom minus the 7 root 5, but remember, top and bottom. And I got a 4 out the top, which is no fun. Take your time. What do I get when I do first on the top? 10 root 3. I'm sorry, 10 root 9, which is 10 times 3, which is 30. But listen, man, take your time if you want. Write 10 root 9 if you need to. Who in here makes errors occasionally? Who makes errors a lot? Who wants to cut down on those? Do less in your head. Write 10 root 9. And then outer, negative 14 root 15. Inner, negative 20 root 15. Last, positive 28 root 25. And on the bottom, what's magical about conjugates? The OI cancels in the FOIL. So I'm not even going to write it. You can if you want. I'm going to go first times first, 25 root 9, minus last times last, 49 root 25. Now, you may in your head be able to simplify a lot of that. That's totally fine. But if you make errors, do this. This is like half your credit. The other half is just simplifying. If you don't show me this half and you're right, no worries. But if you don't show me this half and you're wrong, I don't have anything to give you credit on. So what does this first term turn into? 10 times 3, 30. Next term, can't do anything. Next term, can't do anything, but what can I do with the two of them? So negative 34 root 15. Last term,
140.
140, because 28 times 5 is 140. And then on the bottom, what does this become? 25 times 3, 75, minus 7 times 5, 35. And there's one last thing I can do. Sorry, that is not right. 49 times 5 is 245. Sorry. And then what can I do left? What's left to do?
Add 30 and 140.
So 170 minus 34 root 15 all over a
Negative 170.
negative 170. Is there anything I could do with this?
Take out a 17.
Y'all see that?
Yeah.
If you see that, that's awesome. If you can't, you can start with dividing a 2 out and then just keep going, right? Because I can actually do a little bit more than a 17. I can do a 34. But you can maybe start seeing that as you start one bit. And then do I ever want a negative on the bottom? So top by a negative, bottom by a negative. And then if I cancel a 17, it's like putting this over this if you want. Or just say, hey, 34 goes into that, negative 5, right? 34 goes into that, positive 1, so I'm just left with the root 15. And 34 goes into that, positive 5. And that's pretty nasty too. And again, not everybody's giving you problems that have 5 million things to do. But anyway, hey, what about the reciprocal of this? Believe it or not, that's been a math team question so many times. Find the reciprocal. Guess what people do to miss it? They do this, the reciprocal. Is that the reciprocal of this? No, that's the reciprocal of each part subtracted. I want the reciprocal of the whole thing. What's the reciprocal of the whole thing here? 1 over all of it? Are you done?
No.
So I gotta not only put 1 over it, but then I have to what? Rationalize it. So I'm not gonna do the math on this because I want to keep going, but you would just rationalize the top and the bottom and yada, 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 right? You with me? Actually, maybe I will do it. Okay. 5 minutes. Really need 7. You smell it? It smells like a power square.
Oh,
Towers.
I don't quite have the time, but it's coming.
Oh, yeah.
I tell you this, I know I have the time on review day. I know that, so it's coming, but it's probably gonna happen before the review day. As soon as I have a 7-minute window, 6-minute window, I got it right here, ready to go. Who's ready for it, you think?
I'm doing it right now.
Yeah?
I can take it.
Okay.
Take me 30 seconds.
I think Sam can do it in 30 seconds.
Well, hey, if you can get under 35 seconds, which is, I've had maybe 10 people ever, But if you can, you're making 26s out of 20s. That's 6 bonus points on a test.
What do you
Every
got?
time you do it. Sorry?
Is
Oh,
it a
I need to
minute?
study
I
for
need
that.
that.
If you are, I don't remember exactly. Oh, I haven't shown you this. Here. This is my rubric. I think I'm done right here. Here is how I will grade you on it.
And how many are on? There's all of them?
20, always 20.
Oh, so it's 8 listed.
So here's an example of how I grade. So, and I always drop your lowest one. So if you totally bomb it, you're like, dude, I got hammered. This is how I will grade you. So the quiz is on the back, but you'll take the problem, you'll say, I'll be timing it, you'll go, as soon as you're finished, you'll go time. And when you say time, I will say your time. I'll say something like 1:23 or 2:45 or whatever. And you'll write that time down. And then when everybody's done at the end of 3.5 minutes, whether you're done or not, I will go through the answers and you'll be on your honor. Hopefully we're men and women of integrity. We will grade it and figure out how many we missed or how many you got right. So, hypothetically, let's just say you got 18 right. You're going to go number correct. I got 18. Now, normally 18 out of 20 would be a 90. But it's also time-based and it's penalty-based. So every time you miss one, say you did it in a minute and 23 seconds, which would have put you on this interval. Okay? Since you missed 2 questions, you drop 2 intervals. So it's like basically like a 30-second penalty. You take that number, which is your multiplier, I call it, and you would multiply 18 by 0.92, and your score would be a respectable 16.56, which is roughly an 82% on your test.
Ah,
Okay? Now, if you got all of them right, okay,
36.
in a minute 23. A minute 23 is in that perfect interval, it's a 1.0, you would get a 20 out of 20. Okay? But if you start beating a minute 30, like if you are under a minute 15, your multiplier goes to 1.05. If you're under a minute, it goes to 1.1. If you're between or under 35 seconds, it goes to 1.3. And your score is always out of 20.
wait, what?
But if you come in here tomorrow or whenever I give the quiz and you don't know jack, and I call time and you've only done 11, you're gonna and say they at least of the 11 are correct. But at time you got a 0.68 multiplier, because that's the lowest multiplier there. And I can't go any lower on the intervals, so I'll show mercy and give you a 0.68. Then you're gonna go 11 times 0.68, and you're gonna be grateful that your 7.48 gets dropped out once. And then at that point, maybe you'll take me seriously and go make some flashcards. Yes?
If you just kept getting like 22s out of 20, like on all of them, would they keep adding up? Or do they like?
It's like an
cancel?
extra 2 points on your test.
What's the number range?
Because I put this in the test category, tests and quizzes. So anything over a value is like just bonus points.
And this is a quiz grade?
And this is a quiz grade, but it's in the test category. So again, anything over 20 just acts like a bonus point on the test. It's the same equivalent.
What's the range? Is it like 2 to 8?
Oh yeah, I test you through 2 to the 12th, right? Through 3 to the 8th, 4 to the 6th, and 5 to the 6th.
Alright.
I'm not going to give you anything other than up through these numbers. And since there's only 20 of them, I'm probably not going to have 2 squared on there or 3 squared. Or they're all basic ones, right? Because there's 12, 20, there's 32 here. So I probably will pick the 20 of the hardest 32, the higher powers, right? You with me? Oh, and one last thing you may not know. You cannot show scratch work. No. So if you don't know 2 to the 12th off the top of your head, good. You can't go, oh wait, 2 squared is 4. 4 times 4 is 16. You can't just show any multiplication. Any multiplication, that's penalties. Or even on your desk. I came by one day, some guy finished the quiz and there's like stuff all over his desk. If you haven't memorized, you got a fighting shot to do really well on it. Y'all be going.
Dude, I had all of them like 15 seconds. They're all saying it.
Yeah.
All right,